Alright, what's going on, guys? Welcome back to the channel. It's been like 2 weeks since I posted, but you know what? We're going to be posting every week from now on. Alright, but anyways, we're going to be doing another breakdown. Okay, we're going to be doing passage 3 because a lot of the pre-meds in my tutoring program are like, yo, Eric, I do not understand passage 3. I do not understand those questions. I do not understand the explanation that the AMC provides you for these questions. And honestly, some of the explanations from the AMC are pretty crap. Okay, I'm sorry AMC to just like shit on you guys, but y'all explanations are not good. Only like some of them are good, but majority of the time AMC explanations, they fucking suck. All right, so this is passage 3. I want to see what all this fuss is about, so I'm going to be doing a breakdown of this passage and these questions here. So as always, guys, go ahead and do the questions first before I break this down. Okay, so this is the first question here. This is the second question here. This is the third. This is the fourth, fifth, sixth. That's it, right? Yeah, that's it. Okay. So go ahead, guys. Do these first. And then here, this breakdown. And I'm going to tell you what all this fuss is about this passage. Why is everyone complaining about this passage, okay? I'm going to make this simple for you guys. I'm going to show you guys that it's possible to do this, okay? So the pace that I read, this passage is the same pace that I read passages when I'm doing the MCAT, okay? It's not like a fast pass. I don't read fast, okay? I don't skim through it. I read at a good pace, okay? A regular reading pace that's a little slower, okay? A little slower than your regular reading pace that you're reading like a book, okay? That's all I do. So let's begin. Let's make this make sense. Let's show you how to break down this complicated passage because apparently this is like the hardest passage there is, but we're gonna make this easy, okay? Ready? 2 minutes on the clock. As always, guys, I don't edit these videos, okay? This is a straight up one-time attack that I'm doing on this passage here, okay? If you look at the time, it's not edited at all. I do this straight up one time, and if I get these wrong, then fuck yeah, I get it wrong. I'll still post it, but let's attack this. Let's see what it's about. Enough talking. Let's get into it. All right. Researchers investigated the effect of pH and compound 1 concentration on liposome formation. Liposomes are synthetic spherical lipid bilayers that mimic a cell membrane. And this is compound 1 here. Okay, they tell me exactly what the heck this whole entire passage is going to be about. Okay, I don't have to highlight this. I would highlight it, but I'm not going to. Okay, they told me everything this passage is going to be about. All right, what's it going to be about? Well, they're investigating the effect of pH and compound 1 concentration. What they're going to do, that I bet you $1 million they're going to do, is they're going to say, okay, if I change the pH, how does this affect liposome formation? If I change compound 1 concentration, how does that affect liposome formation? If I change both, if I keep one constant or the other one different, if I have this one different and this one different, if I mix these both, all right, all these different things, okay? They just want to see how the heck does pH and compound 1 concentration affect liposome formation. That's it. That's all you have to take from this, okay? That's what the passage is going to be about. I'm sure they're going to manipulate those variables. Okay, look, pH 10 or above, below, different concentrations, okay? That's simple here. I have an idea. Let's proceed. This is compound 1. You should know the structure. Okay, you should know the structure. Liposomes were synthesized from 1 milliliter of various concentrations of compound 1 at pH 7 by ultrasonication and agitation in the presence of fluorescent dye that emitted light at 520 nanometers when excited at 460 nanometers. Okay. 1 milliliter, okay? They were synthesized from 1 milliliter of various concentrations of compound 1. That's the concentrations they manipulated, okay? We're at pH 7, ultrasonication and agitation. What the heck is that? I'm guessing this is some type of aggressive research approach here that they're doing to these liposomes. Okay, they threw dye in here. They threw compound 1, they threw dye, and this is the way that the dye fluoresces. And it makes sense here, you know. We have an excited state, and we have a lower energy state. That's exactly how fluorescence works. An aliquot of the liposomal suspension was subjected to size exclusion chromatography. You should know what this is, 100%. You should know what this is. And results are shown in figure 1. Further aliquots of the liposomal suspensions of compound 1 had their pH adjusted from 2 to 12. Results from size exclusion chromatography indicated no changes occurred. Okay, so from 2 to 12, when they adjusted their pH, no changes occurred for compound 1. Cool. And that's the figure. Okay, they're just collecting data here. Nothing too crazy. Don't look at figure 1. Let's keep going. We only have a paragraph left to read here. Liposomes generated from oleic acid, compound 2, gave similar results to those shown in figure 1 only at a pH of 8.5. Okay. At pH 10 or above and pH 7 and below, liposomes of compound 2 did not form. Okay, when we're at those crazy pHs, okay, compound 2 liposomes, they don't form. The researchers mixed liposomes of different sizes and observed that those formed from compound 1 were stable to mixing, but mixing those from compound 2 formed new liposomes with an average size expected for the effective final lipid concentration. Okay. This paragraph here, okay, specifically this last sentence here, a little interesting here. This is interesting. Okay. Compound 1, stable. Compound 2 forms new liposomes. All right. And then at these harsh pHs, liposomes from compound 2 don't form. Okay. Very easy passage, guys. It's not that bad. I don't see what the fuss is about, okay? This is very simple here, all right? You should know what liposomes are. You should 100% know that they're like, liposomes are like a micelle, okay? Except that they have that cavity. They have a cavity in the middle, okay? And this cavity can have aqueous solution in here, okay? So let's go to the questions. Compound 1 is a member of which class of lipid molecules? All right, compound 1 this is a simple pseudo-discrete question here. If you don't get this right, it's because your content review is off. Okay, you should know what this is. This is a phosphatidylcholine head group here, and this is a fatty acid tail. I see a double bonds on saturation. Okay, you should know what that is. It's not a triacylglycerol. Triacylglycerol has like carbon, 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 OH, OH, OH. Pyrophosphate, I do not see a pyro ring or none of that. Phosphatides, yes, this is a phosphatidylcholine group. Phosphonic acid, no. Answer C for this one. Pretty simple, straight up. You should not get this wrong. If you do get this wrong, go over lipids, okay? Your lipid content is off. So that is correct. Why do the liposomes fluoresce during size exclusion chromatography? Okay, size exclusion chromatography, you should know what that is. It's simply the big things, they go first, and the small things stay behind, okay? That's basically what size exclusion chromatography is. It is a little backwards because I know you're so used to like electrophoresis and SDS pages and all that stuff, and in electrophoresis and SDS pages, these small things go first, okay? But in size exclusion, the big things go first. Anyways, why do they fluoresce? Simple question here. The macromolecule had extensive conjugation. No, this is not extensive conjugation at all. Okay, that is obviously wrong. Fluorescent dye was trapped inside. Maybe. Let's see if there's a better answer though. Intermolecular interactions lower the energy of the excited state. Okay. You may be tempted to click this answer choice. Okay, but this answer choice is wrong. Why is it wrong? Well, you need to know your fluorescence. Okay, fluorescence happens when we go from a ground state to an excited state, and we come back down, and as we come back down, okay, we lose energy, and that energy is obvious that we lost it because we see a different color, okay? This energy, let's say in this case, okay, at 460, we get excited to 460 nanometers, and then we lose energy, and we release that energy at 520 nanometers. Remember, nanometers is backwards, okay? The higher nanometers, less energy. Lower nanometers, more energy. All right? So that's how fluorescence works. We get excited and that electron jumps, okay? Now, intermolecular interactions is not how fluorescence works, okay? Fluorescence has nothing to do with intermolecular interactions, okay? It doesn't matter if compound 1 interacts with compound 2 and then they form some type of bond and this bond is like really strong or weak. Like, no, that's not about fluorescence. Fluorescence is just going from an excited to a non-excited state. You don't need to complicate it with this intermolecular interactions. They're trying to trick you here, okay? It is true this is half right, okay? It's true that when we lower the energy of the excited state, we get fluorescence, but it's not true that it's because of intermolecular interactions, okay? So this is wrong. All right, I'm going to try to speaking a little faster throughout these. I don't want to waste you guys' time. All right, I'm just trying to show you what goes on in my mind as I go through these questions. All right, light reflects from the surface of the sphere. This is wrong, okay? If you chose this, it's because you had no idea and you probably guessed, or you just said, okay, this sounds pretty right. Let me just choose this. Like, no, okay? What sounds right is what you believe is right, okay? If you believe this is right, then it's probably going to be right. If you think, okay, this might sound right, so this could be right, it sounds right, no, none of that. I don't care if it sounds right. You have to believe that it's right, all right? This is wrong. This just makes no sense. Why are we talking about reflection here if we're talking about fluorescence here, okay? Answer is B, through process of elimination. Also, it kind of makes sense, okay? Liposomes, they have that cavity, like I said. And what they did here is they threw compound 1 in a solution. When they threw that compound 1 in the solution, that solution contained fluorescent dye, all right? I'm sure that those liposomes were formed and trapped that fluorescent dye in the middle, specifically in their cavity, okay? And through ultrasonication and agitation, this aggressive technique here, the cavity was broken up a little bit or completely broken up. And because that cavity was broken up, that dye that was trapped in there was released. When that dye is released, it's able to fluoresce. Okay? Boom, B. All right. The way that I was able to extrapolate and make that assumption, how did I know that the dye gets trapped in there? The way I was able to make that connection, it is a little out there, okay? Like, you do have to know that the dye was trapped in there. It's like, oh, how did you know, Eric, that the dye was trapped in there? You do have to make that. Hypothesis in your head, okay? So let's move on here. All right. You should know what liposomes are. If you know what liposomes are, you can have that hypothesis in your head and make that conclusion that the fluorescence gets trapped in there. That cavity matters. Liposomes is a little low yield, but you do got to know what that is. All right, let's move on. What does the behavior of liposomes prepared from compounds 1 and 2 upon mixing indicate about the energetics of their transformations? Liposomes prepared from compound 1 and compound 2 under kinetic, okay. So they want to say, okay, is compound 1 kinetic or thermodynamic? Is compound 2 kinetic or thermodynamic? Let's find out. Okay, you should know what thermodynamic control and kinetic control do. You should know that the conditions under which something is kinetic and which something is thermodynamic. You should know what a thermodynamic product looks like. You should know what a kinetic product looks like, okay? What you have to know here, okay, this is a straight content review that you should know in your head. And if you don't know this, you have to go back and go over this specific topic here. In my head, I'm thinking from my content review, okay, kinetic goes fast and we get an unstable product. Thermodynamic goes slow and we get a stable product. Okay, kinetic is irreversible and thermodynamic is reversible. Those are the things you have to know. So using that knowledge, we're going to answer this question here. The researchers mixed liposomes of different sizes and observed that those formed from compound 1 were stable to mixing, but mixing those from compound 2 formed new liposomes with an average size. Okay. All right. Compound 1, stable to mixing. Compound 2, new liposomes. All right. Okay. They don't tell me about the specific activation energies. All right. They only tell me that compound 1 was stable to mixing. They tell me compound 2 forms new liposomes. Okay, this is a tricky question here. This is a hard question here. All right. All right, what they're trying to get at here is, okay, the way I'm going to answer this question is like this, okay? They don't tell me about the activation energies, okay? They don't tell me about the specific rates. They're not like, hey, compound 1 goes at this rate and compound 2 formation is at this rate. They don't tell me that. They tell me new liposomes are formed and this guy's stable. And that in compound 2 they did not form at specific pHs. All right. So they're going after the the specific knowledge that thermodynamic forms reversible reactions and kinetic forms irreversible reactions, okay? Compound 1, okay, is under kinetic control because it does not form new liposomes, okay? Because it does not form new liposomes, it is an irreversible reaction. Compound 2 forms new liposomes, and because it forms new liposomes, that is a reversible reaction. Okay, those new liposomes can form, they could come back, they can form here. Okay, they're new forms here. They go back and forth. Compound 1 was stable and does not make new forms. Okay, look, it says here, different sizes, and observe that those formed from compound 1 were stable to mixing. All right, you have to assume that compound 1 does not make new forms. If it does not make new liposome forms, it is an irreversible reaction. Therefore, compound 1 is kinetic. And compound 2, because it forms new liposomes, expected for the effective final lipid concentration, meaning that those that are formed are expected meaning that they are the more stable product. So compound 2 forms new forms, and they form one that is the most stable. All right, that's what thermodynamic control is. Compound 2 for 100% is thermodynamic control. Okay, so this is wrong and this is wrong. Compound 1, I'm going to go with kinetic control. Although it does say stable, okay, they're trying to get at reversibility and irreversibility here. So I'm going to go with B. I'm pretty sure it's right. I'm not 100% sure it's right. Okay, like I score very high in this section. Okay, I scored a really great score in this section, and I'm not entirely sure that this is correct. Okay, it's okay if you're not 1,000% sure. Okay, but I do feel really good about this answer. Okay, I do feel really good about B. This is a hard question, guys. Okay, this is a pretty tough question here. Okay, if you get this wrong, do not worry about it. I would consider this question so hard that it's a little unfair. Okay, I'd say this is unfair here because this is so tricky here. They say stable to mixing, okay, and they don't really give you much here. I'm gonna go with B here. It's a very hard question. I'm not trying to save my ass, but I'm gonna go with B here. I don't think they're both under thermodynamic. There's obviously a difference here, so I'm gonna go with B. Oh, let's go. It's correct. All right, let's do this. Awesome. Yeah, that's the explanation here. This is a hard question, so do not feel bad if you get this wrong, okay? But you should know certain things here. B is a correct answer, 100%, okay? All right, this one. The diameter D versus elution volume V for liposomes using identical chromatographic conditions is shown. Let me give you a little chart here. Using the ultrasonication agitation method of liposome preparation, what concentration of lipid is necessary to prepare liposomes with a diameter of 250 nanometers? Okay, whenever you see a table like this, look for a pattern. Look for a pattern right away. What pattern do I see here? As we increase volume, the diameter decreases. Okay, as we increase the diameter, the volume decreases, the elution volume. 250 is an increase in the diameter, so our elution volume will decrease. Okay, it's going to be decreasing. Now I can use this to see what specific volume. All right, so I'm going to use a pattern here. When we go from 50 to 150, when we go up by 100, the elution volume gets halved. Okay, 30 and half is 15. When we go from 100 to 200, just like before, we go up by 100, the elution volume is halved. It gets divided by 2. It goes from 20 to 10. Okay, so using that, all right, if we go from 150 to 250, we're going to half the elution volume. This is going to be a halved. So this is going to be 7.5. Okay. Let me draw out something here. Okay, I think I'm gonna use Zoom here to annotate on this. Okay, let me bring up Zoom here. Okay, let me share the screen. We'll share this. We're gonna annotate here. Okay. So here to here, we get plus 100. Okay. And then here to here, we divide by 2. All right, so I'm gonna use that, using that here. When we go from 150 to 250, we're going to divide this by 2, and this is going to be 7.5. The elution volume for 250, oh shit, the elution volume for 250 is going to be 7.5. Okay, 7.5. And they want to know the concentration of lipid to prepare this. Okay, that's elution volume. So the concentration 7.5 corresponds to what? Let's look over here. So an elution volume of 7.5 is around here. Okay, it's around here. So what is this concentration? Well, we have 0.20 here, and it goes down this way. All right, and it goes up going to the left. So the concentration at 7.5 elution volume is going to be greater than 0.20. Okay, it constantly goes up here. It's increasing this way, and if we keep going this way, it's going to be an increase of 0.20. All right, what's higher than 0.20 of these answer choices? D. D is the only one that's higher than 0.20. So I'm going to go with D as a correct answer. That is my thought reasoning towards this. Okay, if you look at patterns, and also this is the only one that's not here. Okay, if you look at patterns, then you can get the answer choice correctly like that. Okay, D is a correct answer. I knew it. All right, let's look at this one. What mass of compound 1, molecular weight 800 grams per molar? Okay, as soon as they give you something here, guys, this is the biggest hint in the world. Molecular weight. Okay, molecular weight, I'm pretty sure the only equation that you know that has molecular weight is mass over molar mass equals moles. Okay, I'm pretty sure that's the only one you know. So that's probably the one we're going to use here. So we have molecular weight of 800 is contained in solution used to prepare liposomes that elute at 20 milliliters by size exclusion chromatography. They want the mass. Okay, we know that mass over molar mass, okay, equals moles. So we want mass. We have molar mass, which is this, and we need moles. So we need moles. When we have moles, we can multiply that by this, and we get mass. So let's find our moles. How do we find our moles? Well, we know that the concentration at 20 milliliters, okay, we know that concentration. What is that concentration here? The concentration at 20 milliliters elution volume is 0.10. Okay, 0.10 millimolarity. The big M stands for molarity, guys. Molarity. Okay. Now, molarity and moles, they are not the same thing. Okay, they're not the same thing. Molarity, okay, is moles per liter. Molarity is moles per liter. Okay, so we have to change, I'm going to erase this here. We have to change 0.10 millimolarity into moles. Okay, if we do that, we can find the moles here, multiply by this, and get mass. How do we do that? It's very simple, guys. Okay, 0.10 molarity. Okay, I'm going to use this unit so it's a little easier for you guys to see, is moles over liter. We multiply this by a liter amount, specifically the total volume of this, okay, the total volume that this was taken from. What is the total volume that this was taken from? It is taken from 1 milliliter, okay, 1 milliliter. So 1 milliliter. I'm going to erase this here. You know it's 1 milliliter. All right, liters cancel out, and then we're going to get moles. Use that moles, plug it in here, multiply it by this, and we get the mass. Okay? We don't use this volume. Okay, I'm sure you guys were probably tempted to use this volume, 20 milliliters, especially since it was right here. Okay, 20 milliliters is the elution volume. Elution volume is the liquid, the solvent they used to get this liposome, to get it out of the column. All right, so if this was the column here, I know I'm giving you guys a lot of information here, but I really want you guys to understand this, okay? This is my thought process, and if you really want those 131, 132 scores, guys, like this is what you kind of have to know, okay? So the size exclusion chromatography, okay, they have different things here. Okay, I'm going to use like this here. Hold on, let me redo that. Okay, so size exclusion chromatography, the big things fall down first, and the little things get stuck here, okay? They get stuck. So if something is stuck here, they use an elution volume, okay, that's the solvent needed. They add that here, and then these little things, they fall out eventually. They get unstuck, okay? That's basically what happens here. So what we're going to do is multiply 0.10, okay, millimolar, multiply that by 1 milliliter, okay, multiply that by the molar mass, which is 800 grams per mole. Okay, we do that, and then we should get the answer. And I'm going to do this in my notebook here so it goes a little faster. Okay, you have to convert all these to scientific notation. Okay, convert them to scientific notation so it's easier. And I'm going to do this really quick here. You should get... Okay. You should get 8 times 10 to the negative fifth. 8 times 10 to the negative fifth is 80 micrograms. Okay, the answer is A. Okay, if you need me to do this math out, just send me a comment down below. I'll do the math out for you and show you guys how to do it. All right. So let's continue. All right. Liposomes derived from compound 2 are prepared at pH 8.5 from 2 different solution concentrations, 0.10 millimolar and 0.20 millimolar as described in the passage. What is the expected appearance of the size exclusion chromatograph of the liposomal suspension that results after mixing equal volumes of these? Oh, this is really easy, guys. Don't overcomplicate this, okay? They mix these two. Mix them, okay? Find the average of this. It's 0.15, okay? 0.15, this is 2. There's 2 things added together. So we're not going to have 1, 2, 3. These 2 are going to be combined, and we're just going to have 1, 2. Okay, makes sense? And it's at 0.15. All right. 0.15 is like right here. Okay, so I'm looking for a big peak here. Okay, which one is that? That one is this guy. Answer is D. Okay, very easy, guys. Don't overcomplicate that. All right. And that's it. And that is it. Okay. So, was that passage hard? Yeah, that was definitely more difficult than the other ones, but it was definitely not impossible, okay? If you read at the pace I was reading at, okay, this question was definitely a hard one, okay? This one was definitely hard. The other ones were definitely, easy and attainable. This one's, I would say it's a little unfair. Definitely would say it's a little unfair, so don't get too worked up if you don't get that one right. But yeah, this was a little longer, guys. If you need me to go over the math, if you like this kind of style better where I bring the annotation, I write down on this, to show you guys what I'm thinking. If you do like that, comment down below. Yeah, so my tutoring program, it is not available right now. There's no more spots available. They will be available in the next coming 2 weeks. I'll have another spot available, so send me an email to get on the list for that. Love you guys. Go ahead, crush the MCAT. I'll see you guys in the next video.